Dear students, today we are going to discuss class 12th, chapter number 15, organic compounds, page 107, 107. Topic is functional groups and homologous series. So, let me define what is functional group. Remember that functional group is an atom or group of atoms or a bond which imparts characteristic properties and chemical reactivity to molecules. So functional group can act as a boss, or you can say it's a king of molecule. It may be an atom or a group of atom, it can be a single bond, it can be a double bond, it can be a triple bond, but it controls all the reactivity of a molecule. Similarly, the organic compounds are also classified on the basis of functional groups. So functional group also provides the basis to the classification of organic compounds. So this is actually the identity of organic compounds. So it determines the identity of organic compounds. So this is the very reactive part of the molecule. For example, if any molecule reacts, first of all the functional group reacts. Let me give some examples. For example, let me draw a molecule here. This is called ethyl alcohol. Ethyl alcohol. Similarly, there is another compound. This is called methyl chloride. Methyl chloride. Or let me draw this structure. This is ethene, the second member of alkene series. This is an alkyl halide, this is an alcohol. So, is by the definition of functional groups, an atom or a group of atoms or sometimes a bond which impart specific properties and chemical reactivity to the organic molecules. So look at this compound. There are how many atoms? There are 4 atoms, but not all the atoms, only this chlorine atom is the functional group. Here in this molecule, not all the atoms, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 atoms are there. But this group of atom, which is called hydroxyl group, this is the functional group. So functional group can be an atom, can be a group of atom. Let me draw another structure. Look at here. This is the formula of acetic acid. In this compound, C double bond OOH, COOH. This is the functional group. So, and similarly in ethene, the carbon-carbon double bond is the functional group. For example, in ethine, carbon-carbon triple bond is the functional group. So functional group can be a bond, can be an atom, can be group of atoms. So I hope this will be clear to you. Now let me proceed further towards the types of the functional groups, and we will discuss it in detail. Remember that there is each and every organic compound has 2 parts. For example, this is methyl group and has OH attached with it. This is called methyl alcohol. Each organic compound is composed of 2 parts: functional group part and hydrocarbon part. This is functional group part. Functional group part. And this is hydrocarbon part. Functional group part is always an atom or a group of atom, or it can be a bond, whatever I have said, we have discussed about. But the hydrocarbon part is always an alkyl group. It may be hydrogen, but it always an alkyl group. So let's say this is the methyl, ethyl, propyl, isopropyl, butyl. These are the alkyl groups. Alkyl groups are the groups which are obtained by the removal of one hydrogen from corresponding alkane. So this is an organic compound. This organic compound is composed of two parts. One is the functional group part and other is the hydrocarbon part. Hydrocarbon part is normally the alkyl radicals, while the functional group part can be an atom, group of atom, or a bond. So alkyl groups are normally represented by R and OH. So ROH is the general formula of this family of compound, which is alcohols. Here R may change, but is for alcohol, the OH will remain constant. All alcohols must have OH group. So, and R may change, it may be methyl, ethyl, propyl, or very complex, maybe benzene ring or something else. So normally there is a question in the bottom of the page 107, that how a functional group is important to organic chemistry. What is the importance of functional group, or how important or how the functional groups are important in organic chemistry? There are 3 points written in your book at the bottom of page 107. So the first point is the functional groups serve as basis for nomenclature of organic compound. Nomenclature means to give the name. For example, this is organic compound. It has the functional group OH. So this compound belongs to the family of alcohols. So this means functional group provides the basis for classification. Basis for classification of organic compound. If different compounds have the same functional group, all of them will belong to the same class or same family of organic compounds. So this is the basis for classification. Similarly, in the second point, they have discussed that functional groups serve to classify organic compounds into classes. All compounds with the same functional group belong to same class. So remember that if we have different compounds, but if they have the same functional group, remember that they will belong to the single family. Similarly, in third point, they have mentioned that the functional group is the site of chemical reactivity in a molecule containing the functional group. Remember that functional group is a radical part. Radical part means it is highly reactive, you can say, a hot part of the molecules. If this molecule react, first of all the functional group will react. If something else, other particle, any electrophile, nucleophile attacks over this molecule, the first attack will take place over this functional group. So it is just like the front line squad in an army. And its defeat will be the defeat of the overall army, and its victory will be regarded as the victory of overall army. Now we will discuss the functional groups and different classes of organic compounds. For example, this represents a family or class of organic compound. This will be here. These are the functional groups. This is their general formulas, and these are the examples. Let's say, first of all, let me take alkane. Alkane have carbon hydrogen single bonds and carbon carbon second bonds. So according to some chemists, carbon hydrogen bond is the functional group. According to some other views, carbon carbon is carbon-carbon single bond is the functional group. But and some books say that there is no specific functional group in alkanes. So these two are written in our books, so we will just follow these two. General formula is RH. R represents alkyl group and H is hydrogen. Examples are methane, ethane, propane, butane, pentane, hexane, and so on. Another class is the alkene. Here ANE of an alkane is replaced by ENE, alkenes. Alkenes are characterized. You can identify an alkene by the presence of carbon-carbon double bond, and this is the functional group in alkynes. The general formula may be carbon-carbon double bond here, or these may be alkyl groups, or these R can be the hydrogens. So here R represents hydrogen or alkyl groups. Examples are ethene, propene, butene, pentene, hexene. Many examples are there. The next is alkyne. In alkynes, the ANE of alkane is replaced by YNE. They have carbon-carbon triple bond as a functional group. General formula is RC triple bond CR. Here R may be hydrogen or alkyl group. Examples are ethyne, propyne, butane, pentane, and many others. The next class of organic compound is arene. Arene is actually those compounds which have a benzene ring, and this benzene ring is the functional group in such compounds. And arenes are, they have general formula AR, AH, where AR for arene or aromatic hydrocarbons. Excellent example is benzene. C6H6 is the formula of benzene. Now move towards halides, or also called alkyl halides or haloalkanes. These are the organic compounds which contain X attached singly bonded to carbon, any carbon. Here X may be any halogen atom. You know, in periodic table there is group 7 which contain fluorine, chlorine, bromine, and iodine. Astatine is also there, but astatine is radioactive, so we don't count it here. So here the functional group is halogen atom. So this is the functional group, and they have the general formula Rx. R is any alkyl group, and X represents any halogen atom. Example is methyl chloride. You can also take methyl bromide. You can take the example of ethyl chloride, propyl chloride, isopropyl chloride, butyl chloride, and many others are the examples. So this was about the halide. Now alcohols. Alcohols have functional group OH group. OH group is the functional group in alcohol. It is normally bonded with a carbon atom. That's why carbon atom is mentioned. But the reactive part is this. They have the general formula ROH. R represents alkyl group, so R can be methyl, ethyl, propyl. I have given the example of methyl alcohol. So those compounds which have OH is a functional group, they are called alcohols. So this is the family, our class name is alcohol. The next is ether. Ether are a bit changed in the sense they have an oxygen atom singly bonded with two carbon atoms at the both sides, and the two carbon atom may belong to alkyl or aryl groups. So carbon at the both sides and oxygen in the center. This represents the functional group in ethers. General formula is ROR. R may be, they may be same or different, and oxygen is you can say it both are present at the either side of the oxygen atom. Example is methyl. This is the alkyl group. This is another alkyl group. Oxygen in the middle, dimethyl ether. This is an example. So now we will proceed towards the amines. Uh, Remember students that for example if you are going to a bazaar or market, you will feel the fishy smell of fishes near the fish market. So there, the fishy smell in fishes is due to the presence of a class of organic compounds which are called amines. They have very unpleasant smell. So these are called amines. Some people also pronounce it amines, but whatever it is, amines is the class of organic compounds in which nitrogen is linked with open chain carbon, and at this side of the nitrogen there may be R alkyl groups, or it may be a hydrogen atom. It may be a hydrogen atom. So their general formula is RNH2, and these two hydrogen can be replaced by the alkyl groups R. So this then represents the various classes of amines, which are the primary amine. If one R is present, so or one hydrogen substituted by one R, it is called primary amine. If both the hydrogen are replaced by two alkyl groups, then they are called secondary amines. So these are the different classes of organic compounds. Similarly, there's a first, this is the primary amine, and when one hydrogen is replaced, they are called secondary amine, and when both of the hydrogen are replaced, then they are called tertiary amines. Similarly, the example is methyl aminomethane, or you can say methylamine. This is the name of this compound. Now, in other classes, nitriles, they have carbon and nitrogen triple bond is a functional group. So this is the functional group in nitriles. This can be a hydrogen carbon, and it may have hydrogen atoms here or other alkyl groups. General formula is R. R is a very simple or complex alkyl group, and carbon triply bonded with nitrogen atom. The excellent example is methyl nitrile or methyl cyanide. Similarly, the nitro compounds have two oxygen atoms connected with the nitrogen, and nitrogen in turn is connected with the carbon atoms. These carbon atoms may have hydrogen or other alkyl groups. So this is the functional group of nitro compounds, and general formula is RNO2. Example is nitromethane. The next class is sulfides. They have two carbon atoms at the either side of the sulfur atom. Sulfur is connected with the two carbon atoms at the both sides. These may be the alkyl groups, maybe aryl group, some aromatic compounds, aromatic group. Both are at the both sides of the sulfur. This class of compound is called sulfide. The excellent example is methyl sulfur methyl dimethyl sulfide. This is an example of this class of compound. So these are called sulfides. Sulfooxide is just like the sulfide, but sulfur is also connected with the oxygen. So look at this functional group. Sulfur is connected with coordinate covalent bond with oxygen, and both sides are occupied by the carbon atoms of alkyl groups. So these may be the alkyl groups. So that's why the general formula is RS bonded with one oxygen. These are called sulfooxide. For example, dimethyl sulfooxide. This is the name of that compound. Now the next is the sulfone. Sulfone is analogous to sulfooxide, but there is a big change. The only change is this, that here two oxygen atoms are bonded with sulfur, while in sulfooxide there was only one oxygen atom bonded with sulfur. The rest of the arrangement is same. So in this functional group, sulfur is bonded with two oxygen atoms, at the top and bottom side, and at the right and left they have two carbon atoms of alkyl groups. That's why their general formula is RSOO, or they are called sulfones. For example is if the alkyl groups are the methyl groups or dimethyl sulfone. This is an example you can check in your book. Now the next class of compounds is the thiol. Thio means sulfur. For example, sodium thiosulfate. It means this compound contains sulfur. And normally the sulfur compounds give very disagreeable smell. For example, onion soup, for example, garlic. They have some sulfur compound. That's why they have some smell, some bad odor. So thiol, here sulfur atom is connected with the hydrogen at the one side and carbon of any alkyl group at the other side. So this is the functional group in thiols. The general formula is RSH. The example is methyl thiol or thiomethane. So this is also called methyl mercaptan. And remember that this compound is present in natural gas, and the bad smell or unpleasant smell of the natural gas during the leakage, it's due to the presence of this compound. And it is interesting to note that it is present round about 0.001%. I mean, this compound is present in very small quantity, but still it gives so much bad smell. So if it was present in amount of 1%, 2 or 10%, I think this would be very dangerous situation. So this was about the thiol. Now we are proceeding towards the carbonyl compounds. Remember that carbon can form 4 bonds. If carbon form double bond with oxygen and 2 valencies left, this is called carbonyl group. This group is called carbonyl group. Now I will put different groups or atom across this carbonyl group, and we will get the different classes of compounds. For example, if I put an alkyl group or aryl group here and hydrogen atom here, this class of compound is called aldehydes. For example, acetaldehyde, it is alkyl group at the one side, but the functional group in this compound is an aldehyde is this group. It is called formyl group. Now, if I put 2 alkyl groups at the either side of carbonyl carbon, again here alkyl, no hydrogen. This class of compounds is called ketones. For example, nail polish remover, what we call acetone in our ordinary life, or which is also used as a glass cleaner. This is ketone. Ketone is also present in the urine of the diabetic patients. This is the formula of acetone. This is the acetone, are also called dimethyl ketone. So I think you would have learned the difference between the aldehydes and ketones, that aldehydes have alkyl group at the one side and hydrogen at the other side, while in ketones both sides around the carbonyl carbon they are occupied by alkyl groups. These alkyl groups may be similar or dissimilar, they may be simple or very complex. Now this was about the aldehyde and ketones. Both are called carbonyl compounds. So that's why in your book when they were discussing about the carbonyl, aldehyde and ketone is written in front of that functional group. So now let me proceed towards the carboxylic acids. Again, let me take carbon doubly bonded with oxygen, one valency left, other valency left. If I put alkyl group here and hydroxyl group here. This constitute what? Carboxylic acids. This is the general formula of carboxylic acids. And the functional group in carboxylic acid is this group, which is called COOH group. This is called carboxylic acid group or carboxylic group. The excellent example is acetic acid, which is the, you can say, a necessary part of or component of vinegar, silica. And so acetic acid is present in vinegar. It has the functional group. This is called carboxylic group. This is the functional group, and it may change. So again here we have R and functional group, which is the COOH. So this is the general formula of alkyl group of the carboxylic acids. Now I shall replace the OH group of carboxylic acids by various other groups, and we will get some other classes of organic compounds. For example, let me proceed. If I replace this OH group by NH2 amino group, we will get a class of compound with formula RC double bond O NH2. Here both hydrogen can be replaced by alkyl groups, remember that. So if you remember that we have discussed the amines. In amines, NH2 group was attached to an alkyl group, but this class of compound is called amides. And in amides, the NH2 group is attached to carbonyl carbon, not to the alkyl group. So this is the difference between the amines and this amides. So this is called, amides are called carboxylic acid derivatives. There is another carboxylic acid derivative. For example, if I replace this OH group of the carboxylic acid by X. X means fluorine, chlorine, bromine or iodine. I mean a halogen atom. So if we put a halogen atom here, this class of compounds are called acid halides. They are called acid halides. For example, CH3, C double bond O Cl. This is called acetyl chloride. This is an example of this class of compound. These are called what? Amides. So now the next is the esters. If we replace the OH group of carboxylic acids by OR, for example, OH is replaced by OR, I shall get such a compound. This class of compounds is called esters. This is its general formula, and remember that here the functional group is the ester linkage. This is the functional group. The both alkyl radicals may be similar or they may be different. For example, let me write the formula of an example of such a class of compound. What is this? Methyl, and this group is called acetate. So the name of this class of compound is esters, and this compound is called methyl acetate. Similarly, they can, if I replace the methyl by ethyl, then it is called ethyl acetate. If I replace again here by ethyl, it is called ethyl propanoate, and so on. Now, if we join two carboxylic acids together, for example, look at this, R C double bond O OH, R C double bond O OH. Again here R C double bond O OH. If I remove a water molecule H2O and connect these two parts together, for example, if I start from here, R, C double bond O, O, C double bond O, R. These are called what? Acid anhydrides. These are called acid anhydride. Anhydride means anhydrous. Hydrous from hydro, which means water. So this compound is produced by the removal of water from two carboxylic acid molecules. So that's why this class of compounds are called acid anhydrides. Acid anhydride. Anhydride means without water. The example is if I replace the R by a particular alkyl group. For example, if I place methyl here, this is called acetic anhydride. Acetic anhydride. So this was something about functional groups. We have discussed many classes of functional groups and many functional groups and different in terms of different families. We have also written their general formulas with the suitable examples. Now let me proceed towards my next topic, that is the homologous series. So first of all, let me define what is the homologous series. Before going into the detail of the definition of homologous series, let me draw alkane series. You know alkanes. First alkane is methane, formula CH4. Second is ethane, C2H6. Third is propane, C3H8. Fourth is butane, C4H10. Fifth is the pentane, C5H12. Similarly, hexane, C6H14. Now, let us check the difference between any two adjacent members in this series. This is the alkane series. This is alkane series. 2 carbon, here is 1 carbon. Subtract this carbon from this. 2 minus 1, what we get? C. 6 hydrogen, 4 hydrogens. Subtract it. So we will get 6 minus 4 equal to 2. This is called methylene group. This is called methylene group. So the difference between the first two compound is this group or this unit. It is called methylene group or methylene unit. Now again the difference between these two, the second and third, 3 minus 2, 1 carbon, 8 minus 6, 2 hydrogen. Again the same is the difference here. 4 minus 3, 1 carbon, 10 minus 8, 2. Again the same is the difference. 5 minus 4, 1 carbon, 12 minus 10, 2 hydrogen. So in this series, any two members, adjacent members, never compare this with this, but the adjacent member, consecutive members, they differ from each other by one methylene group. Such a series of compound is called homologous series. So what is homologous series? Homologous series is a series of compounds in which two adjacent or consecutive members differ from each other by a constant unit of one methylene group or methylene unit. So such a series of compound is called homologous series. Each individual member is called homologue. And the whole series of compound is called homologous series. Similarly, if I write the alcohol, various alcohols, methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol, pentyl alcohol, remember that. Now check the difference. OH minus OH, they are cancelled. 2 carbon minus 1 carbon, I get 1 carbon. 5 minus 3, 2. Again there is a difference of 1 CH2 group, methylene group. Check these two. 3 minus 2, 1 carbon. 7 minus 5, 2. So here again the difference between any two adjacent member is this methylene group. So this constitute another homologous series because there is a difference of one CH2 group between any two members or adjacent members of this series. So each homologous series represents a class of compounds or a family of compound. Homologous series means a family, a class. Alkane is a separate homologous series, alkene is a separate homologous series, alkynes is a separate one, alcohol is a separate one, carboxylic acid is a separate one. So there are few points after this topic in which they have discussed about the characteristics of a homologous series. So let me discuss it in a simple way, in a brief way. Remember that there is a difference of one methylene group, CH2 group, between any two adjacent members of homologous series. This is the first characteristic of homologous series. The second point is this, that all the members of the homologous series, let's say I have written the alcohol series. What is the functional group in all these three compounds? OH, OH, OH. So remember that in a particular homologous series or in a particular family of compounds, all the members have same functional group. And remember that chemical properties depends upon functional group. When functional group is same, this means the chemical characteristics or chemical properties, the chemical reactivity of these molecules is same. So all the members of a particular homologous series they are chemically identical, they have same chemical properties. Why they have same chemical properties? Because they have identical functional group. For example, OH is the functional group in alcohols. So similarly, all the members of a homologous series can be prepared by a single general method of preparation. For example, if you have any one method of preparation of methyl alcohol, by using the same method you can also prepare the ethyl alcohol. By using the same method you can also prepare the propyl alcohol, and so on. And finally, remember that as we go down, the molecular mass increases. For example, methyl differ from methyl by one CH2. So when we add this CH2 with methyl, it gives us this. And if we add this CH2 group with this, we will get propyl. And if we add this CH2 group with propyl, we will get butyl, and so on. So as we go down the series towards the higher members, the molecular mass increases. Due to the molecular mass increases, the mass of the molecule increases. And remember that the physical properties like the melting points, boiling points, density, viscosity, they depends upon what? They depends upon what? The molecular mass. Greater the molecular mass, greater will be these parameters. For example, as we go down towards the higher members, they will have greater melting points, greater boiling points, greater density, greater viscosity. The state may change. So the physical properties gradually changes when we move from one member to other member. So this was a detailed description of the functional groups and homologous series. So you can go to your book, you can study it, and if there is any question, please contact me. I thank you all.